Okay, so this is going to be the last video in this discussion here. Let's finish out the video for finding this last formula. I can shift this around a little bit. I can simplify this, and some of you that are less secure in your algebra skills are going to find this uncomfortable. Again, I'm not asking you to be able to do this. I just need to show you where these formulas came from so that you're not just sitting here, Marshall just makes us memorize formulas and doesn't show us where they come from. Okay, so let's rearrange this. Let's put the 2 under here and we'll create this. We'll say x equals x0 plus, and I'm going to switch the characters here. I'm going to say plus v plus v0 times v minus v0, and let's not have that little dot in there. V minus v0. I don't know why I put the 1 in there either. V minus v0. Okay, so all I did was I switched the order of these and put these, and then let's just put this all over 2a. Okay, so the first thing I'm going to do is I want to rearrange this, and ultimately I'm going to get my final velocity on one side and everything else on the other side. Okay, so ultimately I'm going to get my final velocity on one side and everything else on the other side. Okay, so in order to get final velocity on one side, I'm going to need to get rid of the 2a and the x, the initial velocity. So I'm going to subtract this. I'm going to subtract x0 from x and get that on the other side. So now I have x minus x0 equals v plus v0 times v minus v0 all over 2a. Now I'm going to get rid of this denominator. Okay, I'm going to multiply this on the other side by 2a, and so I'm going to say 2a times x minus x0 equals v plus v0 times v minus v0. Now, if I remember my algebra, if I were to multiply this out, this is the same thing as a difference of squares. Okay, I'm going to end up with v squared, okay, plus, or v squared minus v times v0 plus v times v0 minus v squared. So I'm going to end up with this 2a times x minus x0 equals v squared. Okay, so v squared minus v0 plus v0 minus v0 squared. Okay, that's going to drop out. So I end up with v squared minus v0 squared. And I'm going to add the v0 squared to the other side of the equation. So I'm going to end up with v squared equals v0 squared. So if I, again, added v0 all the way over here, v0 squared plus 2a times x minus x0. And this is our last formula. And in fact, we'll end up calling this the last formula because it's the last in the list, and that'll be helpful to us as well. But we're going to call this displacement with, I'm sorry, not displacement, my bad. We're going to call it, because what we end up with is final velocity, right? So final velocity with constant acceleration You're like, well, wait, Marshall, we've already got one of those too. I've got final velocity with constant acceleration. But we're going to distinguish this one by saying no time. Final velocity with constant acceleration, no time. And yes, I know this is v squared, but we're still just going to say final velocity. Okay? So that's this formula, and now we have completed our 5 formulas, and now we'll go ahead and summarize these, and then in the next lecture we'll say how we're going to use them. Okay?
Okay, so I've given you a summary of all of the names and all of the formulas that you're going to use or have available to you. You'll get these on all tests. You'll never have to memorize these, although again, I'm sure some of you actually will, and it will help your problem solving immensely if you have a good knowledge of these. And then also remember that the average velocity can be determined by the following if acceleration is constant. So average velocity, if acceleration is constant, equals 1/2 times the initial plus the final velocity. Okay? So let's go ahead and finish this, say this is done, and move on to how are we going to use these in section 1.5.